Let's now look at questions pertaining to boats. So let's look at what information needs to be given to us. Suppose we are talking about speed of boat in still water. So now what we are talking about is the current or the stream plays absolutely no role. Even if there is no speed of the current, this is the speed at which the boat would move in still water. Suppose we take that as A. And then let's assume we say speed of the current by itself is B. We need to understand two terms here. One which is upstream speed. By upstream what we mean is the boat is moving against the current. And if the boat has to move against the current, then upstream speed would be nothing but A minus B. And then we have a term called as downstream speed, which would mean that the boat is moving with the current, and hence the speed of the boat when it is moving downstream would be A plus B. So if speed of boat in still water is given to us and speed of current is given to us, then we can find upstream speed and downstream speed, and then hence look at the question asked, which could be in terms of time taken and so on, and we can use these two formulae to answer the question. However, there are certain questions where the upstream speed is given and the downstream speed is given, and we need to find the speed of boat in still water or the speed of the current. So if we want to express the speed of boat in still water in terms of these two, looking at the right hand side, if we add the two, B would cancel off and we would get 2A, and hence we can say that A would be equal to half of upstream speed plus downstream speed. So if the upstream and the downstream speeds are given, then half the sum would give us speed of boat in still water. On the other hand, if we want to find the value of B, and if we look at the right hand sides, if we subtract the two, which means if we subtract upstream speed from downstream speed, we would get 2B, and hence we can say B is equal to half of the difference of the speeds. So if A and B are given, then we can find upstream speed and downstream speed. However, if upstream speed and downstream speeds are given, we can find A and B. These questions on boats normally are very simple to solve. Let's now move on to races along circular tracks. So let's look at this circular track, and let's assume the length of this circular track is 120 meters. Suppose this is the start point, and then we say that there are two people A and B. A is moving in the clockwise direction, so is B. They are moving in the same direction. A is moving at a speed of 5 meters per second and B is moving at a speed of 3 meters per second. Now in these questions of races along circular tracks, there are two kinds of questions which are typically asked. And these two questions are, the first one is, after they start, and they start together, after they start, in how much time will they meet for the first time? So the first question is, after starting, after how much time will they meet for the first time? And the second question is, after how much time will they meet together at the same start point? So let's understand the difference between the two questions. The first question talks about meeting for the first time, which could be anywhere on the track. And the second question is meeting for the first time at the start point itself. So we'll try and answer both the questions for this particular case. Now if A and B start at the same time from the same point and they move in the same direction, since A speed is more than B, it is clear that A is continuously going to keep moving ahead of B. And if the question is after how much time do they meet, the only way they can meet, and this is something that any F1 fan can very easily understand, that the only way they can meet is if A completes one full circle extra over B, which basically means that A is going to move ahead, keep moving ahead, and actually cover the distance of the entire track extra as compared to B, and hence come from behind and meet B at some point. Now, since we know that the only way they will meet is if A covers, and it is A because A is faster of the two, if A covers one full circle over B, then we know the formula for time is distance upon speed. Distance that is to be gained by A is equal to the length of the track, which is 120 meters, and speed now will be the concept of relative speed, which is going to be the difference of the two since they are moving in the same direction. So it would be 120 divided by 5 minus 3, which gives us 60 seconds. So the answer to the first question, which was after how much time will the two meet for the first time, the answer is 60 seconds. Now if the question asked is after how much time will they meet for the first time at the start point, then the answer now would depend on in how much time do these two people A and B individually reach the start point. So if we talk about A at the start point, which would mean to cover a distance of 120 at a speed of 5, A takes 24 seconds, which tells us that A will be at the start point every 24 seconds. And if we say B at the start point, and if we do a similar calculation, it would be 120 upon 3, which would make it 40 seconds. So this tells us that B is going to be at the start point every 40 seconds. Now if we want both of them to simultaneously be at the start point, then my answer would be LCM of 24 and 40, which would make it 120 seconds. So we've answered both the questions. After how much time will they meet for the first time? It is 60 seconds. And after how much time will they meet at the same start point? It would be 120 seconds, which is nothing but LCM of each person's time to reach the start point. Now this was an example where we had the two people moving in the same direction. However, if we make a minor change and if we say that A is moving in the clockwise direction and B is moving in the anti-clockwise direction, which means that they are moving in opposite directions, and if we have to answer the same question, in how much time will they meet for the first time, the answer would now be distance upon speed, which is 120, which is the length of the track, divided by speed, which is the relative speed. Now it would be 5 plus 3 because they are moving in opposite directions. So now my answer would be 15 seconds is the time in which they will meet for the first time. If I want to answer the second question, which is in how much time will they meet at the same start point for the first time, the answer wouldn't change, because whether they are moving in the same direction or opposite directions, the answer depends on each person reaching the start point, and hence we know that A would reach at the start point every 24 seconds, B would reach at the start point every 40 seconds, and hence both of them would simultaneously reach the start point at a time which is the LCM of 24 and 40, which is 120 seconds. So this was a case of a circular track race involving two people. Having seen a question of circular races involving two people, let's now look at a question of circular races involving three people. So suppose this is a circular track of length 120 meters. Once again, this is a start point from where three people start at the same time and they move in the same direction. So suppose we have A moving at a speed of 5 meters per second, we have a person B moving at a speed of 3 meters per second, and we have a third person C moving at a speed of 2 meters per second. So we have three people ABC moving in the same direction clockwise, starting from the same point at the same time. Circular track of length 120 meters, and we need to answer the same two questions, which would be, when do these three people meet for the first time after they start? And the second question would be, when do these three people meet at the start point for the first time after they start? Now when we look at these three people, we need to break it up into two problems of two people each, which would mean we first take, let's say, A and B together. And when we are considering A and B and we want to see after how much time do A and B meet, it would be the same concept as earlier, which would be 120 would be the distance to be covered, which is the length of the track, divided by 5 minus 3, which would be the relative speed of A and B, and this would give us 60 seconds. So this tells us that A and B meet every 60 seconds. Now if we want to look at A and C, the calculation would be 120 divided by 5 minus 2, which would make it 40 seconds. Now based on these two calculations, we would know that A and B meet every 60 seconds, A and C meet every 40 seconds. Now if we want to find a time when A, B and C meet, then such a time has to be a multiple of these two, and hence it would be the LCM of 60 and 40, and the answer hence would be 120 seconds. So all the three people meet for the first time after 120 seconds. If the question now is, when will all three people meet at the start point for the first time after they start, the method would remain the same, which is we find each person's time of reaching the start point. So A would reach the start point every 120 upon 5, which is 24 seconds. B would reach the start point every 120 upon 3, which is 40 seconds. And C would reach the start point every 120 upon 2, which would be 60 seconds. And my answer would now be LCM of 24, 40 and 60, which would be 120 seconds. So here we find that whenever they meet, they always meet at the start point. How do we know that? They meet for the first time, which could be any point on the track after 120 seconds, and they meet for the first time at the start point also after 120 seconds, which tells us whenever they meet, they will always meet at the start point. Now this is specific to this question, and this cannot be generalized as a rule. If we now take a variation where we say that A is traveling in the anti-clockwise direction and B and C are traveling in the clockwise direction, and now if we want to find out in how much time do they meet, how would the calculation change? Now only for convenience sake, to have simple numbers, I am changing the length of the track to 112 meters. So my calculation now would be A and B would meet every 112 divided by 5 plus 3, which would be 112 divided by 8, which is 14 seconds. A and C would meet, if we make these changes, 112 divided by 5 plus 2, which would be 16 seconds. And hence if all three people have to meet, then ABC would be LCM of 14 and 16, which would be 112 seconds. So the only change here, because the direction changes, would be in terms of the concept of relative speed. Everything else in terms of the method would remain the same. Having seen the concepts of circular races, let's look at one more concept now. Suppose you are told A overtakes B for the first time in the middle of the fourth round. We are now talking about a circular track, start point, A and B moving in the same direction. They start at the same time, And then it is mentioned that the first time that A overtakes B, after they start, the first time is in the middle of the fourth round. Now, if it is in the middle of the fourth round, it means that at that particular moment, A has completed 3.5 rounds, and since we already know the concept that they will meet the first time only when the faster one completes one full circle extra over the slower one, it would mean that B has completed at that particular instant 2.5 rounds. So when A overtakes B for the first time in the middle of the fourth round, it means that A has completed 3.5 rounds, B has completed 2.5 rounds, and since this is what is completed in the same time, the ratio of their speeds would be 3.5 to 2.5, which is nothing but 7:5. So based on the statement given to us, we can actually find the ratio of their speeds, because we know that they start at the same time and this is what they have achieved in the same time after starting. So let's go back to the adventure that we started off with. We have a bank which is located at a point. Suppose this is the point where the bank is located on the circular road. The thieves that have committed a robbery and are fleeing in their jeep along this circular road. The circumference of this circular road is 2200 kilometers, and if we use our concepts of geometry and if we say 2 into pi into r is equal to 2200, then we would get r is 350 kilometers, which means the diameter is 700 kilometers. So this length is 700 kilometers. This is the point that the police want to intercept the thieves at, which is diametrically opposite the bank, which tells us that the police will have to cover a distance of 700 kilometers. The police start chasing the thieves only after 4 hours, and the thieves are fleeing at a speed of 100 kilometers per hour. So in 4 hours, the distance that is covered by the thieves is 400 kilometers. If the circumference, the entire circle is 2200, then half the circle would be 1100 kilometers, which essentially means from the bank till this point diametrically opposite along the circumference, the thieves would have to cover a distance of 1100 kilometers, out of which 400 has been covered in the 4 hours, and hence the remaining distance that the thieves will cover would be 700 kilometers to reach this point. The police also has to cover a distance of 700 kilometers. Hence what we can conclude now, if the police just run at or just move at a speed of 100 kilometers per hour, which is the same as the speed of the thieves, then the police will intercept the thieves at this particular point. So the answer to the question is the speed of the police should be 100 kilometers per hour. So this is how, having gone through our concepts of time, speed and distance, and in fact also incorporating a few concepts of geometry, we could answer this question.